Hey everyone, and welcome to week 5. This week we're going to go over joins and functions. And to kick this off, we're going to go ahead and review last week's quiz. If you haven't done last week's quiz, please do so as soon as you can. I don't want to have to start docking points for tardiness. So, question 1. How do we select all orders placed in May 1997 and May 1998? Basically, this is a case where we're going to use the between operator that we talked about in last week's video. So we're looking for basically this one right here, select all from Northwind orders where order date between 1997 or May 5th, 1997 and June, or not May 5th, I can't talk today, May 1st, 1997 and June 1st, 1997, or order date between May 1st, 1998 and May 1st or June 1st, 1998. The next question, we cannot rename output columns in our SQL statements. That is false. We can use column aliases to rename our output columns. Question 3, provide the SQL to retrieve all orders shipped by either Speedy Express or Federal shippers. And this is one where we're going to use our in operator, right? So we're going to say select all from orders where shipped via in, and then we're going to use that subquery that we used last week. Select shipper ID from Northwind DBO shippers where company name is equal to Speedy Express or company name is equal to Federal Shipping. I think this tripped up a lot of people. I think a lot of people were just selecting simply the shippers. I was looking for the orders shipped by specific shippers. And like I said, we use the in operator to pull that data back. Question 4, provide the SQL to output the total value of chai in stock, the quantity times value as a column named total chai value. And so this one I think tripped a lot of people up as well. And this one was actually pretty easy. And really all we're doing here, we are recording, right, is we're saying select quantity. Well, what was the, let's see here. Okay, well I've got the SQL right here. So we're going to say select unit price times units in stock as total chai value from products where product name is equal to chai. And we come up with $702 worth of chai in our products. And if we look at our products table, so we have chai is the product name, we have a unit price of $18, and we have 39 units in stock. So really what we're looking for is this 18 times 39, and then we want to output that as total chai value. And finally, provide the SQL to retrieve all orders that have no ship date. And this one should have been, I don't think anybody's missed this one yet. Select all from orders where ship date, I think it's ship date. Was it ship or shipped? Shipped date. Oop. Is null. And that is our quiz. So, like I said, now I want to get into the actual content for the video, right? And this week I want to go over joins. So our first video is going to be on joins, and our second video is going to be on functions. if you recall from last week, we talked very, very briefly about functions in that we use the sum function, and there's other functions that we're going to talk about this week. But I want to talk about joins right now. And what is a join really? A join just lets us combine columns from two or more tables into a single result set, right? And so what I mean by this is if we look at our Object Explorer and we look at Northwind, and some of you ran into this issue in the first quiz, right? So you have orders, in which you have a set of orders, but then you have a second table called order details. And what confused a lot of people, I think, about this was that there was a constraint placed on deleting orders where you have to delete order details as well. And so really, if we look, right, so we have an order ID and orders. So let's now pull the data back from order details. And you could see we have an order ID, we have a product ID, we have a unit price, a quantity, and a discount. But this order ID matches an order ID from orders, right? So 10/248. So now let's run our query again. Where order ID equals 10/248. So you could see there's related data. So really a join allows us to pull this related data back. And so there's a few different kinds of joins, and the first one we're going to talk about is going to be an inner join. And the inner join is the most common join. It's probably the simplest to use, the simplest to understand. And really, what an inner join does is lets us pull data from two tables where certain conditions match. And so the syntax for this is really easy. Select star from, say, orders, join order details on orders dot order ID is equal to order details dot order ID. And so let's break this syntax down a little bit, right? So it's still a select statement, but now we've added this join keyword, and we've said, all right, so we're going to join order details on, and we use the on keyword to specify what columns we're from our first table are going to map to the columns on our second table. And so if we look at, so we say orders.order ID equals order details.order ID. And basically what this is doing is this is saying, all right, give me all of the records from give me all of the records from order details that have corresponding order IDs in the orders table. And so if we scroll way over, you can see now after ship country we've started our order details. So all of this is orders. This over here is order details. Pretty easy to use. Now there you can specify inner join and get the same result set. Generally speaking, you'll just say join. It's implied that when you say join, you're going to be doing an inner join. There's something we're going to talk about in a minute called outer joins that require us to specify either left, right, or I'm forgetting the last keyword on that on outer joins. Full. So left, right, full before the join. But generally speaking, when we do inner joins, we're just going to say join because it's just a lot easier to deal with. So, generally speaking, you'll join two tables based on the relationship between the primary key in the first table and a foreign key in the second table, i.e. primary key in orders, and then foreign key order ID, which is both a primary key and a foreign key. You could also do a join on product ID from order details to the products column. So things like that. Now, in certain cases, you will have times where the two column names are different, and I don't think we have an example of this in the Northwind database, so I'll just write up quote-unquote pseudocode for it. So let's say that we have, let's use our existing example. So select all from orders, join order details on orders. Let's say that orders doesn't have a column called order ID, it just has a column called ID. And it's implied that that's the unique ID for the order. So instead of having to say orders.id, we could just say ID equals order ID, which is the equivalent of saying order details dot order ID and orders dot ID. So if the column names are not the same, we don't have to specify the table before the column name in our join portion, this portion right here. But a lot of times you're going to see that the columns are named the same for readability, and so we're almost always going to, for the most part, we're going to see this syntax right here. And so, let me see. We can also use what's known as correlation names to make our SQL a little bit easier to read. In certain cases where we're doing joins from multiple tables, right? And so we can do joins on multiple tables, right? So I can join both order details and products in one SQL query and pull back all of the data, right? And so we can use correlation names, or also known as table aliases, to make our SQL easier to read. So we could say select all from orders, ORD, say orders O, let's say, yeah, select all from orders O. So now, right, so now I've just written a select all and I've given a correlation name or table alias to orders. And basically this is going to work the same as column aliases, right? So I can say select all from orders as O and still get back the same data, or I can remove the as and just say O. So select all from orders O, join order details OD on O dot order ID equals OD order ID join products P on OD dot product ID equals P dot product ID, where O dot order ID equals 10248. So now you can see I've joined 2 additional related tables. Well, I've joined 3 tables total with related data, right? And so you could see up till I get to ship country, I've got my orders, and then I get into my order details, and then I get into my products. Right, so let's see, let's make this a little bit, easier to read, right? So we can do a select all, and we can say, give me all of the data back. Give me everything that is stored in these tables that maps to this data. However, that to be said, as you can see, when we do multiple joins like this, it makes our data really hard to read. Right, so let's make this a little bit easier to read. And we can specify, just like in a regular select statement, only the columns that we want. So let's say o.order ID, od.quantity, p.product name. And so now I can specify just the columns I want, and now I've been able to pull back my order ID, my quantity, and my product name. See, we can see that order 10248 ordered 12 queso cabreles, 10 Singaporean Hokkien fried mee, and 5 mozzarella di Giovanni. And so we have we have made our output a little bit easier to read, right? Or we can always just do the star and pull back everything. So another thing that we can do is we can do what are known as compound joins. And basically a compound join is a join, like I've just mentioned, with more than one mapping column, right? So to speak, right? So select all from orders O, join order details OD on O dot order ID equals OD dot, whoop. Okay, what don't we like about this? Order ID. Okay, now we're working. All right, and we may not actually be able to do this on. We may not actually be able to do this on. We may not have a good example of this. Yeah, I don't think we have a good example of this in our Northwind database. So let's just talk through the basics of it, right? And this is going to be some SQL or some pseudocode again. So in our standard join, we have this query: select all from orders O, join order details OD on O.order ID equals OD.order ID. Now, what I can do with a compound join is I can say after my on, I can say and, or. Let me wrap these in parens to make this a little easier. Whoop. So I could say my standard join, and then I could say and or o dot, let's say, employee ID equals od dot employee ID. And so basically now I've said only join the order details that either have both matching order IDs and matching employee IDs. So if we had an employee ID field on order details, we would be saying, give me all of the orders where the order ID is 10248 and the employee ID, right? So give me all the order details where order ID is equal to 10248 and where the employee ID is equal to 5. And so if there was an order detail where the order ID equaled 10248 and the employee ID equaled 5, we would pull that order detail record back. Unfortunately, like I said, I don't think that we have a I don't think that we have a I don't think that we have a good example of that in Northwind, and that is okay, right? So you're not this. I mean, you're gonna see this if you work with SQL out in the real world, but you're not gonna see it nearly as much as you'll see just a standard inner join. And so the next kind of join I want to talk about is a self join. And a self join is where a table is joined with itself. And so basically, self joins are pretty rare, right? You don't often see tables being joined with themselves. But a self join is basically going to look like select distinct O1 dot let's say ship name from orders O1 join orders O2 on ship address equals, if I can type it right, O1.shipaddress equals O2.shipaddress. And so basically I've done a join on my what was I going to say, on my table. But you'll notice that because I have specified distinct on ship name, but I've specified O2 ship address, I'm not getting distinct records back anymore. So there's, like I said, there's a very, very, very rare occasion to use a self join. So that to be said, we're gonna move on. So we've already talked about doing joins with multiple tables, and if we recall, doing joins for multiple tables just looks like this. So pretty easy to understand. Now, what we can do to simplify this even further, or maybe make it harder to read, right, is we can do what's known as we can use what's known as implicit syntax, right? Up till now, we've been using explicit syntax with our joins. So we've been specifically saying, I'm going to join these two tables um, using the join, or I'm going to join these two tables, and I specify that using the join keyword. But I can do this implicitly just using a where clause. And so what this looks like is I can say select all from orders, order details, where orders dot order ID equals order details dot order ID. And so now you can see I've pulled back the exact same data, but I haven't used the join keyword. And so that is known as the implicit syntax for doing a join. So basically what we're doing is, instead of coding the join in the from clause, we're coding it in the where clause, along with, which arguably can make it easier to read, right? And so I have my from, I have my where, and now I just add an and condition, and orders dot order ID equals uh, 10248. And so now I have done the exact same join I did up here. Man, these keyboard shortcuts are killing me today. Oh, that's the one that it didn't like. Right, so this down here, this is the same as saying this. But if you look at it, realistically, it's taking up about the same amount of space. Personally, I think using the join is easier to understand, but that's me. And that'll probably be our discussion board question for the week, right? So what is the easier? Do you find it easier to understand the explicit or implicit join syntax? And so now I want to talk about outer joins. And outer joins are similar to inner joins, but the difference is basically, instead of pulling all of the rows that match the conditions, we also pull back. So basically, an inner join retrieves all the rows that satisfy the join condition, whereas an outer row pulls back all of the rows that satisfy the join condition, plus the unmatched rows in one or both tables, right? And so when we do a join, when we do an outer join, we're going to use pretty much the exact same syntax, right? So the difference being is we're going to specify a keyword left, right, or full. And so what a left join does let's get rid of this where condition here. Let's actually get rid of this and see if we have any. Okay, so this is a bad example. Let's do this. Select all from where details OD. Okay, I need to find a good example of this. Suppliers, supplier ID. Join suppliers S on P dot supplier ID equals S dot supplier ID. Okay, here's what we're gonna do. I know what we're gonna do. Let's add a new record to our suppliers table. Update supplier or insert into suppliers values. Oh, let's supplier ID. Chef supply. All right, let's do this. Select all from suppliers. Okay. All right. So now we're working with something here. Okay, I screwed something up. All right, what did I screw up here? You know what? We're just gonna roll with it. Okay, so if we go back to our table, right? So we know we have 30 rows, and you'll notice, so we have 77 products. Actually, let's flip this. From suppliers S join products P on S. Whoop. Supplier ID equals P dot supplier ID. Okay, so let's just pull this. Let's pull the supplier ID S dot supplier ID. P dot product name. And then order by S dot supplier ID. All right. So as you'll see, we have 77 products, and we have 1 through 29 supplier IDs, right? But you'll notice supplier ID 30, which is the one that we added, is not included. And so if we do a left join, what we do is we pull back all of the records from, so basically a left join pulls back all of the records from the first table, even if there aren't matches from the, even if there aren't matches in the second table, right? So we pull back all the suppliers, even if that supplier does not have any corresponding records in the products table. And, whoop. So now what I can do is I'm going to add a new record to products, and we'll say pork rinds, um, 34. Whoop. Oh my God. 34. Pork rinds. Category ID 2. Quantity per unit. Excuse me. And we'll say 30000 34 0 reader level 12 false. Okay, so there's a constraint on it. All right. Okay. Anyway, so like I was saying, so basically, well, actually, we can just do this, and we can just, whoop, we can do basically the same insert but flip the join, right? Or the same join but flip the order. So select P dot product name S dot supplier. We'll say S dot supplier ID from suppliers or I'm sorry, products P, right join suppliers S on P dot supplier ID equals S dot supplier ID order by S dot supplier ID. Okay, and so like I said, so on a left join, we pull back all of the first table, even if there aren't matching records in the second table, right? So we pull back all of our suppliers, regardless of whether there are matches in the products table, or even if that supplier is not supplying any products. Whereas a right join, we pull back all of the products. Whereas, yeah, on a right join, we pull back all of the suppliers. We're basically we're doing the same thing, but we flipped it, right? So now we're pulling all of the second table, even if there are no matches in the first. Whereas in the left join, we're pulling back all of the first, even if there isn't a match in the second. So you could see we've got a null product and a full supplier ID, and if we do it the opposite way, you basically end up with the same result set, but it's looking at it differently. And then obviously a full outer join pulls back all of the records from both, even if there are no matches, right? So basically a full outer join pulls back basically it's pulling back all of both. So basically it does more or less, I think the term I'm looking for here is a Cartesian product, if I remember that correctly. Or I'm sorry, maybe not. But basically no, Cartesian product isn't the right word. So basically you're doing a select all from products and a select all from suppliers. That's what a full outer join will do. And basically it just matches that data regardless. It basically pulls that data back regardless of whether there is a match in this join clause right here. And so now I do want to talk about Cartesian products for a second. And when we're talking about Cartesian products in SQL, we're probably talking about cross join. And a cross join produces a result set that includes each row from the first table with each row from the second table. And basically what this does is basically, like I said, it'll cross join. It'll basically do it acts very similar to a full outer join, right? So select star from products cross join suppliers. And so now you can see instead of pulling back 77 rows, I've pulled back all of the where product name equals chai. So now you can see I've pulled back all of the records of chai and map that to all of the suppliers. Right, so I have 30 suppliers, so therefore I have 30 records of chai and 30 records of suppliers. If we scroll down here, you can see it's even got my supplier that I added. So that is a cross join. Personally, I have never used a cross join in my professional life. But that doesn't mean that there's not a case to use it. Honestly, I've never used a Cartesian join in my professional life either. So, yeah. Let's see, where are we at on time here? We're at 45 minutes. We can get into unions, but I think we'll save unions for next week, or maybe as an add-on. So that's all of joins. And like I said, my next video will be on functions, and there will be obviously a quiz and a database post due this week as well. Please reach out if you have any questions.